Exploration requires mobility. And whether you're on Earth or as far away as the Moon or Mars, you need good tires to get your vehicle from one place to another. Tire development for space exploration has been a focus of research at NASA Glenn for a decade. Evolving since the days of Apollo, NASA engineers started examining tire designs back in the 1960s for use on the surface of the Moon. Three major wheel designs were introduced by NASA and other international researchers for early exploration. While they were vastly different, they were all focused on moving hardware and astronauts across the lunar surface. The Russian vehicle Lunokhod used 8 rigid rim wire mesh wheels with bicycle-type spokes and metal cleats for traction. The American Modularized Equipment Transporter, MET, a 2-wheeled unpowered cart, used smooth rubber tires supported by nitrogen-filled inner tubes and manufactured by Goodyear to make it easier to pull the cart through soft lunar soil and over rocks. The last NASA vehicle to visit the Moon was the Lunar Roving Vehicle. This manned vehicle used 4 large flexible wire mesh wheels with stiff inner frames to prevent over-deflection. Thin tread strips were attached to the carcass to enhance flotation in soft lunar soil. While NASA was developing rovers to send to Mars, there was also interest in taking a new look at returning to the Moon. NASA Glenn engineers rebuilt Apollo-era tires and developed new designs using newer materials and technology to better function on a lunar surface. During the mid-2000s, NASA Glenn engineer Vivekas Nani worked with industry partner Goodyear to develop the Spring Tire, an airless compliant tire that consists of several hundred coiled steel wires woven into a flexible mesh, giving the tires the ability to support high loads while also conforming to the terrain. The Spring Tire has been proven to generate very good traction and durability in soft sand and on rocks. This innovation led to an R&D 100 award for Top Inventions of the Year. A little over a year after the Mars Curiosity rover landed on Mars, engineers began to notice significant wheel damage in 2013 due to the unexpectedly harsh terrain, causing concern about the ability of the rover to drive far enough to complete its intended mission. NASA Glenn engineers thought their work on Spring tires might be a new and better solution for exploration rovers on Mars. So, they set about developing several Spring tire prototypes to improve traction in soft sand, durability, and reduce overall weight. While the tires performed well, there was a problem with the steel wires deforming when rolling over punishing simulated Martian terrain at NASA's Jet Propulsion Laboratory, JPL. The game-changing material that dramatically advanced the development of Spring tires was nickel titanium, a shape memory alloy with amazing capabilities. After building the shape memory alloy tire, Glenn engineers sent it to JPL's Mars Life Test facility. It performed impressively on the punishing track. There are 3 major benefits to developing high-performing compliant tires that are capable of performing in a Martian or lunar environment. First, they would allow rovers to explore greater regions of the surface than currently possible. Secondly, because they conform to the terrain and do not sink as much as rigid wheels, they can carry heavier payloads for the same given mass and volume. Lastly, because the compliant tires can absorb energy from impacts at moderate to high speeds, they can be used on crewed exploration vehicles, which are expected to move at speeds significantly higher than the current Mars rovers. The Curiosity rover's scientific instruments are still going strong more than 8 years after landing on Mars, but the pioneering rover's exploration could come to an end by something far more mundane: its aluminum wheels. Just 16 months into its mission, Curiosity started to show accelerated damage to its treads due to the harsh terrain. One potential NASA solution is now available for use here on Earth, too. NASA's Glenn Research Center in Cleveland developed a super-elastic tire technology that uses a shape memory alloy, SMA. The airless non-pneumatic tire design was originally envisioned for Martian and lunar rovers. Still, under development at Glenn for space applications, SMA tires can travel safely over rocky and sandy terrain. The wires are woven together to create an airless tire structure that has the ability to flex with the terrain, unlike current rigid wheels. The SMA material acts as a shock absorber and can traverse rock-lodden terrain effortlessly without breaking or damaging the tire. Glenn is working to develop a Mars-grade material that greatly improves SMA capability and makes reversible material deformations possible in the harsh Martian environment without sacrificing performance. A proprietary structural design weaves shape memory alloy into a novel pattern that displaces energy optimally, resulting in a smooth ride like a pneumatic tire, but without the need for an inner tube or air pressure. These new METL tires are super elastic, puncture resistant, and will never go flat. While the Glenn team is working to construct SMA tires capable of traveling over red rocks on Mars and craters on the Moon, here on Earth the technology is already finding uses, including bicycle tires. The Smart Tire Company's continued development aims to establish METL tires as the premier high-tech component for the modern cyclist across the road, gravel, mountain, and e-bike applications. In the summer of 2020, the super-elastic tire technology was one of 9 technologies featured in the NASA Startup Studio, which was run by FedTech on behalf of NASA. NASA Startup Studio matches entrepreneurs directly with NASA technologies primed for commercialization and guides customer discovery and product development exercises for Earth-based applications. Much interest emerged from the NASA Startup Studio, including the Smart Tire Company, based out of Los Angeles, which is aiming to take the SMA tire technology to the streets and trails as a functional bicycle tire called METL. According to Earl Cole, CEO of the Smart Tire Company, due to their ability to undergo phase transitions at the molecular level under strain, SMAs are unlike any other material, exhibiting perfect shape memory over time. The result is cycling products that are innovative, lightweight, durable, and never go flat. Earth applications of this SMA technology could extend far beyond cycling. NASA foresees uses in the automotive industry such as trucking, all-terrain, commercial, automobile tires, military ballistic-resistant tires, high-performance sports, commercial aircraft, and even search and rescue missions.